Okay, so good day everyone, good day class, and welcome. This is our fourth module of this course, Introduction to Computing. So today we will be going to explore the topic that it is an absolute foundation of how digital computing works. So we will discuss number system. So uh, while you might think of this as a math topic, understanding the number system is essential of understanding the language of computers. And we'll be looking for how computers think in ones and zeros, and how we, as humans, as students, can interpret and work with the human or the informations. Okay, so let's begin. And before we proceed pala, let's outline first our learning objective. So this module, in the end of this discussion, we should be able to define the different number systems and identify their applications. So we will explore not just what they are, but more importantly, why we use these specific systems like binaries and hexadecimals in the world of computing. Second, you will be able to convert numbers between these different bases. So this is the core skills, that allowing you to translate the value of a human-friendly format like a decimal machine, like a decimal, to a machine-friendly like binaries, and vice versa. And the third one and the last is you will be able to learn and to compute the sum and difference in binary octal and hexadecimal numbers. So again, this will help us to solidify our understanding by performing fundamentals arithmetic directly within these systems. Okay, so let's start to have with the big questions. Why we are studying this? So at the first point, as the first point says dito, understanding the number system is crucial to understanding how computers compute. So when we use a computer, you see text, images, and videos, But at its most fundamental level, a computer is a machine that only understand and manipulate numbers. So everything you see and do on the computer is first translated into a numerical format that it can be processed. Okay? So this brings us the second point. The language computers speak is not English or Filipino, it's binary. Okay? So representing zeros and ones. So the reason for this is physical. So a computer's processor is made of billions of tiny electronic switches called transistors. So for each switch, it can only be one or two simple states. It representing on, representing the flow of electricity, or off, representing no flow. Okay, so we assign the digit state 1 is for on and 0 is for off. So this two-digit system is the foundation of the modern computing. Okay, so we have here, so we will work to work different number system. So we first need to understand the common structure, So these are the two fundamental concepts. First, as you can see here in our diagram, the first radix, okay, tingnan niyo pong radix, or as it's more commonly called the base. So we have here an example of base 10. So the base is simply the total amount or the total count of unique symbols in a system that uses. Okay? So the decimal system we use daily in base 10 because it's a 10 unique symbols for 0 to 9. Okay, 0 to 9. So the second rule, no, the largest symbol in a system is always one less than base. Okay, one less than the base. So for example, in our base 10 system, so the largest digit is 9. Okay, so which is um, 10 minus 1. Okay, so this rule is universal for the base 2, which is binary system. So the largest digit is 1 and the lowest digit is 0. For the base 16 naman, which is our hexadecimal system, the largest digit would be equivalent to 15. Okay? So let's take out here, no, let's look at the example here, no? Um, we have here the number 1125. So this is decimal. So since this is decimal, ang base niya ay 10. So the individual symbol of 1125. So these are digits. Okay? 1125, these are digits. So the small subscript here, yan, tells us the radix or tinatawag nating base. So when kung decimal po siya, so yung radix niya or the base is 10. So now, um, ang pinaka-importante dito is the concept of position of the place value. So for example, a digit true value depends on where it is where it is in the number. So we assign as index of each position, starting with on the right and increasing it to the left. So to find the total value, well, we have here, you will just multiply each digit by its base raised to the power of its index. So for example, we have 5 here. No? First, we have 5. So 5 times 10, okay, raised by 0. So it's, so that's the value, no? So, for example, 2 times 2, 4 times 10, raised to the power of 1. Okay, 2 times 10 raised to the power of 1, then 1 times 10 raised to the power of 2. So now the final one is 1 times 10 raised to the power of 3. Okay, so now we understand the positional structure, which is the key to work with our number system. Okay, okay, so now for we discuss also the number what we are almost familiar with decimal numbers. Okay, so as the point explains, no, here, so this is the base 10 system. So the name base 10 comes from the fact that it uses 10 unique symbols which call digits, no, to represent possible numbers. These are, of course, 0 through 9, and every number you use in our daily life, from our age, for example, to the price of a product, it is represented by uh, using this system, like for example, decimal numbers. So the second point here, um, these digits are often used with a decimal separator. So we commonly know as a decimal point. So this symbol is crucial, no, as indicates the boundary between our whole number part and the fractional part. So for example, we have a price of 99.50, okay, pesos. So the dot separates the pesos from the centavos. So we also use the plus and minus symbols to denote whether the number is positive or a negative. Okay, so the reason here we are starting to familiarize the system is that the rules of decimal, especially the concept of a place value, so we just discussed, no, and apply here for every other systems, number systems, no, we are about to learn, no. Ayan. So this is our foundation. Okay? So ayan. So for example, no, um, so let's try to have more dig deeper na understanding, no. So into most powerful features ng ating decimal system, it is positional numerical system mostly, no. So this simply means that our digit value is determined by its place or position within the number. Okay, so we designated position for its units, like for example ones, tens, hundreds, thousands, and so on. Well, so this simply means that digit values determine its a position with a number. So we have designated position, no, for ones, tens, hundreds, and thousand, and so on. So for the second point, we explain the mechanics of the position dictates the multiplier to be used for that digit. Okay, so the multiplier is always power of 10. So this simply way to think about its position of 10 times more valuable than the position immediately to its right. Okay, so for example, no, let's use the number of 592. Okay, for a while. So let's, for example, no, let's draw. So let's have example of 582. And then the 2 here is the first position. So let's use here the unit place of base 10. So its value is 2 times 1 is equals to 2. And the next value is 8. So 8 times uh, so 8 um, so so the next position, to the left, it's 10 times greater than the unit place. So it's making the 10 power of 1. So now we have 8 times 10 is equals to 80. So now the last position is 5. Then 10 times greater than tens place and making it um, 10 power of 2. So for example, we have 5 times um, 100, for example, is equals to 500. Okay, so this is, so the number 582, it's a compact way of writing 500 plus 80 plus 2. Okay, okay, 500 plus 80 plus 2. So the the fundamental principles of multiplying the digits is the base raised on the power of its position. So it's the key of understanding numbers system, no, other number system. Okay, so next we have binary system. So the most important thing, no, to realize is the binary system works on the exact same principles as the decimal system. So the logic here of positional value is identical. So the only things that it changes is the base. The changes, no? The base is the change. It changes the base. So at the last point stage, for example, the binary numbers system is based on the radix of 2, which is base 2, meaning it composed with two symbols of zeros and 1. So because this is the base 2, so the place values are different, no? Instead of power of 10, for example, 1, 10, and 100, so our place value are now powers of 2. Okay? So as you can see here, one's place is in the 2 of the 2 place, which is 2 of 1, and the fourth place is 2 of 2, and the eighth place is 2 of 3, and so on. Doubling each the move to the left. So this follows the same rule with the decimal, but it adapted for base 2, each place in the number of worth the 2 times, no? So the place to its right. Okay? Ayan. So for example, we have here. So let's talk some practical examples. So on the left side, we have a table showing, no, the decimal numbers of 0 through 10 and their direct equivalents of 4-digit binary, 4-bit binary. So let's see, no, the pattern. So for example, the decimal 1 is 00001, only and the ones place is on. For 2 naman, only in the 2's place is on, we have 0010. Then now look at the decimal 3, which is 0011. So this is because you get 3. So meaning you need have two places, which is the ones place and to be. So the ones place is 2, while in the first place is 1. So meaning since they are all on, so 2 plus 1 is equals to 3. Okay, as you can see there. So another example we have here is 1010. Okay, so for example, we need to have so let's represent here, no? So 1, 2, 4, 8. Okay, so times 2 po siya, no? Kasi base 2 po siya. So 1 times 2, I don't know, 1 times 1, 1 times 2 times 1 times 2, 1 times 2 times 2, no, 4, 1 times 1, then base 2, 2 times 2, 4, 2, 2 times, not 2 times 2, 2 times 2, yeah, 4, 4 times 2, we have 8. Okay, so by multiply by 2. So since this is 10, okay, so this, let's check here if paano tayo makapag-total ng 10. So from this given 4 bits, we have only 8 and 2 to get 10. So meaning, so ito lang yung 1 natin for the second place, first place, and the third place. Okay? So that's how our binary numbers works, no, into decimals. Okay? Okay, so the octal system has a base on radix of 8. So meaning it uses 8 unique symbols to represent numbers. So following by the 8 base rules, no, the digit use to 0 up to the less than the base. So we have the digits of 0 to 7, 0, 1, 2, 3, 4, 5, 6, 7. and you will get the 8 or 9 in octal. Okay, so why we need to have 8 base system? So it serves as a convenient shorthand for a binary, and long string for a binary are hard for humans to read. So the magic of octal is one octal digit to represents the exact three binary digits or bits. So this is because these three bits can create two uh, power of 3 is equals to 8 unique combinations. So for example, from 000 through 111. So it maps perfectly to the octal zeros up to 7. Okay? Ayan. And for the hexadecimal conversions, we have, so, oh no, ayan. So for hexadecimals naman, the number system has a base or radix 16. So, from here, we have from 0 to 9, numbers po siya numerical. From 10 to 15, we have represented from A to F. Okay? 10 to 15 represented A to F. So, meaning 10 represents A, um, 11 represents B, 12 represents the C, and up to 15 represents F. So, so let's try to count this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay? And 16. Okay? So we have here a radix of 16. So the number system conversions. So let's try to explore each, no? So, ayan. So first, binary to decimal. So we have here a steps, no, or rules. So let's start with the first conversion method, and going to have a binary to decimal. So the steps. So let's more a bit complicated, no. So let's try to um, extract, no, each one. So for example, let's convert um, 1101 base 2. Okay, so we have here 1101 base 2. Let's try to have a, yeah. So for example here, so the first rule, we will assign values for the number markers. Okay. So for example, 1 times 1, 2, 4, 8. So now, we already assigned, no, sa position. And now, let's try to multiply. Ay, wait. This is not a, ano, for a while, ha. This is binary to decimal conversion for a while. Sorry. Erase ko muna. Okay. So for example, let's have from 0, base 0, then 1, 2, and 3. So since hanggang decimal po siya, let's extract, no? So we have 1 times 2 power of 3. So this is power of 3. And we have plus 1 times 2 power of 2 plus 0 times 2 power of 1 plus 1 times 2 power of 0. Okay, so 1 times 2 power of 3 which gives us 8 plus for example 1 times 2, okay, power of 1 power of 2 give us 4. Okay, so for 0 times 2 power of 1, so we have 0 times 2 is equals to 0. And the last one we have 1 times 1 is equals to 1. So it gives us 13. So now the quicker way to think no about is to add just add up to the places value for every position where the a a where's the 1 for example in 11001, so we have 1 in the 8 fours in the ones place, and 1 gives you 13. So it gives us also same result. Okay, so that's how binary to decimals conversions. Okay, so again, you have to remember that the binary numbers are based on the radix 2, while the numbers or the decimal numbers are based on the radix of 10. So now we remember also the binary will only represented ones and zeros. So these are the steps. First step is to place a number marker on the top of given digits starting at 0 up to the last digit. So for example, we have 1, 2, 0, 1, 2, and 3. So let's consider that all ones in the given digits that multiply it to the base number of each given digits, which is base 2. So ginawa natin which is base 2. 1 times 2, 1 times 2, 0 times 2, and 0 um, 1 times 2. So, and raise it to the power which the number correspond in the number marker that you place on the top of the given digits. So, ito yung ginawa natin, no? Ayan po. So, you have to multiply each. Okay? Ayan. Okay. So, we have here another example. We have 101 010. So base 2. So we will convert it into decimal conversion. So first, we will now assign a place value index or the number marker to each digit. So we always start, of course, from the far right with position 0. Okay? Tingnan mo yun guys, yung given. And then, so for example, we have 101010. So meaning the position starts are the positions are 0 to 5. Okay, 0 to 5. So we will apply the efficient method. We only need to look at the positions of the digit 1. Okay, because the position of 0 is just also 0 in the total. So for example, we have 1 and the positions have 5, and we have 3, no? So another 1 we have position in the 3, and the third or the last one we have, or the fifth one we have in the position of 1. So meaning we will compute, no? So we take base 2 raised on the power of each, ayan. So 1 times 2, ito po. Then 1 times 2 and 1 times 2. So it gives us 42, no? So the total of this is 42. And don't forget to identify if this is already decimal, so you have to put the base or a radix 10. Okay, so it's clear now. Okay. So,
Luto ka lang. May tubig sa ipon.
babe. Okay. So, let's have a binary to octal conversions. So, in converting the binary to octal, so the process is much faster converting to decimal because direct substitution rather than calculation. So the most important rule, no, the first one we have the octal digits is equivalent to um, three binary digits. So to convert, simply group, no, the binary string into set of three. So for example, we have 10111010. Okay. So for example, no, so since the total digit, no, of octal is equivalent to three binary digits. So you have just group three binary digits starting from the least significant bit in the right side and append zeros to the most significant bit in the left side. So the group does not have enough to form the three binary digits. So meaning you must complete the groupings up to three digits. Okay? So you'll be having a fraction, no? Decimal points. So let's have an example later. So steps in converting binary to octal, you have to group the given digits in three, starting with the zero from the right side. If the grouping is not complete, play zero to complete the grouping. So if you have group into three, you're starting converting already, because it is already complete. And binary digits into decimal values. So the following, the concept is binary digits for 2, 1, starting from the right. So we have here an example. 001. So since ito yung 11011010 base 2 ito. So if we will group this from first group we have here, for example, this one. So I put it here, which is our first group. Then 101 for the second group, 3 second group. Since this last part of a group is only 1, so you have to add zeros, no? So to complete 3 groupings, so add 2 zeros, okay, for the third group. Now, let's simply put markers, no? Considering this is, take note guys, base, ano po siya, um, uh, 8, no? So since this is base 8, so the markers starts with 1, 2, 4, no? So we have 1, 2, 4, another 1, 2, 4, no? So for example, this one, no, 1, then since this is 0, so wala po siyang value. So ito, since we have a value of 1, so automatic po tayo maglagay ng 2 dito. So for the third place, no, which is 4, since the value is 0, So, wala po siyang number. So, dito naman, 101. So, there are two ones. So, from the first place and the third place. So, we have to add it. 1 plus 4. 1 plus 4. We have 5. Then, for the last one, we have only one, no, na 1. We have 1 once. So, only put it here 1. Then, you add it all, or no, you combine it all. So, you have 158 base 8. So, this is how we convert binary to octal conversions. Okay. So, binary to hexadecimal conversion naman, one hexadecimal digit is equivalent to 4 binary digits. Take note, no? So, just group the 4 binary digits starting from the least significant bit on the right side, and we also append zeros to the most significant bit in the left side. So, if the grouping does not enough to form a 4 binary digits, so meaning you must complete first a grouping into 4 digits. So, if you have having a fractional or decimal point, again, you have to append zeros at least most significant bit in the right side of the given digits to complete the 4 or the groupings of 3 bits. So, these are the steps in converting binary to hexadecimal. So, groups the given digits in a 4 starting from the right side. If the grouping is not yet complete, place another 0 to complete the groupings. So, once you group this into 3 digits already, so you may now start converting the binary digits into decimal values following the concept of this one. Starting from the right. Take note ha, starting from the right. So, we have here an example. So, we have a 1101010. So, now let's try to group this. 1, 2, 3, 4. So, this is the one group. And 1, 2, 3. So, the one group here, put it here, no? For the first group. For the another group, since there are only 3, no? Digits, so to complete it, just add 0, no? Just add 0. So, for example, 0, 1, 1, 0. So, now, we have already complete 2 groups, no? So, next, the next step is to simply add all the markers. So, of course, you have to put first the markers on the top of the numbers. So, we have here 1, 2, 4, 8, another 1, 2, 4, 8. So, what's the rule in binaries? If zeros po kanyang equivalent, so the value of the markers up in the upper side of our number, so i-ignore po siya. So, just look only for the number ones, no? For example, dito there are only in the first and the third digits. So, 8 plus 4, we have 10. Okay? So, since we convert it into hexadecimal, so the representation of hexadecimal, since 0 to 9 represents numbers, and for the last for 10 to 15 are letters, no? For example, start 10, which is A, 11, which is B. Okay, so since we have here the total of 10, so you have to put A. Okay, so next group naman, there are only 2, no, digits in the middle. We have 2 and 4, so you have to add here 2 plus 4 is 6. So you combine now the first group equivalent to 6, and the second group is equivalent to 10, which is represented by A. So 6A base 16. That would be our hexadecimal value from the binary 1101010. Okay? So, next to decimal to binary conversion. So, in converting decimal binary to a binary number is done by successively dividing the numbers the decimal numbers by 2 on the left side of the radix. So if you will have a fractional part of the given decimal, successively multiplying to the decimal number by 2 on the right side of the radix. Okay, so these are the steps. Una, divide muna daw yung decimal numbers with the base number, which is 2. Take note ha, divide muna yung whole numbers sa ating base na 2. Then whatever you have the answer, no? Whatever the answer you will get sa division, and you will divide it again to the base 2 until you cannot divide anymore sa ating 2. Okay? So, the remainder you get, that would be the value that you will consider as converted answer. Okay? For example, first, so we will convert again, no? 6, which is decimal, base 10. So, makikita natin siya kung anong uh, representation siya ng number system. Kung makikita po natin yung kanyang base, no? Which is our radix. So, since 6 dito ay base 10 po siya, of course, kung base 10, so we have decimal. Okay? And next, since i-convert po siya dito sa kabila, question mark, so nakita natin na 2, no, yung kanyang radix. So meaning, we will convert this into binary. Okay? So first, i-convert muna natin si i-convert muna natin yung 6 base 10. Okay? So 6 base 10, we have 0, 1, 1. So we have 0, 1, wait lang. Okay. Yeah. So, kung 6 base 10 po siya, so, i-compute po natin siya 1 times 2 base 2. So, 1 times 2, 2 times 2, we have 4. Then, ito naman, 1 times 2, that is equals to base 1. So, we have 2. Then, we have 4 plus 2, we have 6. Okay? So, 6 base 10. So, ang answer po natin dito is 110 base 2. Kasi when we, then, if we compute this base 10, so, for example, first digits, for example, 210. So, kung titingnan natin itong first at saka second digit, since magko-convert po siya hanggang 6, no? We go hanggang 6, so at first the last part is 0. So, the answer is 110. Kasi nga, when we check 0, 1, 2, so, para hindi siya mag-match, anyway, it's 0 naman po dito, so, ignore siya. So, if we compute this, no, 1 times 2 power of 2 is equals to 4, and 1 times 2 power of 1 is equals to 2. So, if we add this, it can give us 6. So, meaning, our value now to binaries is 110. Okay? So, let's try, no? So, this is another way of getting, no, the answer, no? So, let's try 6 base 10. So, since binary po siya, so the rule is 6 divided by 2. So, since 6 divided by 2, we have 3. So, do we have a remainder? No. So, we put it 0 here. So now our first our divisor now is the product, the dividend. I forgot. Okay, so 3 divided by 2. So since 1 po kanyang value, and then we have a remainder 1. So if there is a remainder, you just put the 1 here because we have the remainder 1. Again, let's successively compute. So 1 divided by 2. So 1 siya, no? 1 siya. 0 siya, but there is a remainder 1. So 1 divided by 2, zeros, 0, and we have remainder 1. Okay? So now, in reading this answer, you will now read upward. So 1, 1, 0. So that one now the answer, we get this na the answer, no? Okay? Another, we have 6.625. So una natin kukunin, no, is the whole number. Okay? So paano natin makuha yung whole number? We have 101. Okay? So 101. So for the 625 times point 625 is 0.2 times 2, no? 0.625. So let's try to have 0.625 times 2. So we have 1.25. Okay, then now another, we have 1.25 times 2. You get the answer of no. We have 1.25 times 2. No. Wait lang. So 1.25 times 2. Okay? Hindi rin. Wait. So 25 times 0.25 pala. So 0.25 times 2 equals 0.5. Dapat 0.5 po ito, ha. Mali. 0.5. And now 0.5 times 2, we have 1. Okay? And since wala na po siyang decimal points, though, you have to stop it here. So now, let's read it. 101. So ito yung answer. Okay? So ngayon, how you get this whole number? Okay? So you will be multiplying the only decimal numbers with base 2 until you reach 0 or decimal place. Okay? Ayan. So for 110, so 6.25, So again, let's have instruction first, no? Decimal to binary. Ayan. Okay. So now, we are done with this part. So now dito na naman tayo. So ito yung nangyari kanina, no? 0, 1, 110. Kaya ang sagot dito ay 110. Okay? 0.101. Okay? Gets na natin. Next, we have decimal to octal conversion. In converting the decimal number to GNL, yan. Mayroon na yung tubig.
Ano po?
Hindi sa usap ng bukal yung tubig. Sino ba yan? Nato na kita ang magbili.
Oo lang. Saka
Okay, let's stop first here. Okay, so in converting decimal to octal, uh, it's also done successively dividing, no, from decimal number by 8 on the left side of the radix. So if you have a functional part of a given decimal, successively multiplying the decimal number by 8. So on the right sides of the radix. So we have here the steps. So divide the given number, decimal number, with the base number which converting it to which is 8. So whatever you have an answer no, you will get the divisions of divided again in base 8 until you cannot divide the answer anymore with 8. So the remainder again you will get, so that would be the correct considered no as converted answer. For example, uh, 66 base 10 and we convert it onto octal. So yung first step natin, 66 over 8. So meaning 66 divided by 8. So meron po tayong 2. We have 8. So 8 times 8, 64. Okay. So remainder 2. So we put it here. Remainder 2. So next, 8 divided by 8. So it's 1. But there is no remainder. You have to put it here 0. 1 divided by 8, of course 0. And we have the remainder 1. So now, in reading this, you just read it upward. So 102. So now 102 base 8. Okay, huwag niyong kalimutan. So in decimal and decimal to hexadecimal, converting an hexadecimal to a decimal number to hexadecimal number is done by successively dividing the decimal number by 16 on the left side of the radix, and you will get a fractional part per given decimal, successively multiplying the decimal number by 16 on the right side of the radix. So here are the steps. First, you will divide the given decimal number, which is the base number that you are converting it, which is 16. Whatever your answer you will get, the division will be dividing it again with the base 16 until you cannot divide the answer anymore with 16. So again, the remainder you can get, the one you consider as converted answer. For example, we have here 286 base 10 and convert it into hexadecimal. So first, 286 divided by 16, you will get 17, and the remainder will be 14. Okay, so let's try to compute. No, we have 16 times 17, you will get 272 minus 286, you will get 14. Okay, next, since the answer is 17, no, 17 divided by 16, we have 1, and we have the remainder 1. 1 over 16, 1 divided by 16 is 0, as remainder we have 1. So now our answer is 1114. So since this is hexadecimal, so the representation here of 14 is letter E. Okay, so 10 A, 11 B, 12 C, 13 D, and 14 E. So now 11E base 16. Okay, for octal to decimal conversion, remember the octal numbers that are based on the radix 8, while the decimal numbers are based on the radix of 10. So we remember also that the octal will only represent the value of 0 to 7. Okay, so the steps in converting octal to decimal, you have to place a number marker on the top of the given digit starting with 0 up to the last given digit starting from the right to determine the exponent to use. So considering all the given digits, multiply it with the base number of the given digits, which is base 8, and raise it with the power of number corresponding on the number marker you place on the top of the given digits. Okay, so here are the steps. So for example, 760 in base 8, since this is octal, we convert it into decimal point, decimal conversion. So place the number 761, place 0 to 1, then 7 times 8 base 2, we have 448, then 6 times 8 base 1, so we have 6 times 8 48, then 1 times 8 base 0 is 1, not base 0, power of 0 I mean. So the total of these is 497 base 10. Octal to binary, since the octal digits is the equivalent to primary digits, we just convert the individual octal digits into 3 binary digits. So here are the steps in converting octal to binary. Convert each of the given octal numbers by using the concept of the 421. So place the binary 1 corresponding the given octal number. For example, 761 base 8 is equals to base 2, the binary. So first, we have 7. So if we convert this into binaries, we have 111. Why? Because if 124 gives us 7, So, meaning you have to put all R1. So base 8 po siya. There are base 8 po siya. So, 0 to 7, no? So, 1, 2, 4. So, we have 7. Next, 6. So, tingnan nyo po kung i-convert po natin sa binary. So, if you, since from the first and the second digit, which is 4 and 2, we can get 6. So, therefore, the last part is 0. Okay? Kasi kung maglalagay pa tayo ng 1 dyan, it will give us 7 results, no? Okay, so we have 1, 1. Okay? So, dito naman sa 1, we have only in the last bit. Okay? So, how we convert now, how we represent now to binary conversion. So, una, clear po na natin to. Okay. So, una, 1, 1, 1. Okay. So, 7, no? 6, 1, 1, 0. And the last one, we have 1 is 0, 0, 1, base 2. Okay. Then next we have octal to hexadecimal. When converting the octal digits to a hexadecimal digits, you must first convert the octal number to binary number and group it by 4 and convert a group of digits to hexadecimal by using the concept of 8, 4, 2, and 1. So, if we get digits, it's enough to form a grouping of 4, and we append 0 on the left sides of the digits. So, if the given octal fractions append zeros on the right sides of the given digits. So, steps: convert now our octal digits to a binary by considering each given digits and represent it in binary using the concept of 4, 2, 1. Once it is in binary, so that's the time you can convert the binary to hexadecimal. So there are 2 steps only. So just, for example, 761 base 8. Then convert into hexadecimal. So first, if we get 1, 1, so 7 nga, 1, 1, 1. For 6, we have 1, 1, 0. For 1, we have 0, 0, 1. So, to group into 4, so since 0, 0, 1 for the first group, 1, 1, 1 for the second group, and we have to append 3 zeros to can get one group, no? So meaning there are already 4 groups, 3 groups. So from the first group, we have 0, 0, 1. So we have 1. Then 1, 1, 1, 1. So we have here 15. 15 to. So we have F. Then 0, 0, 1, we have also 1 F 1 base 16. So since 1 hexadecimal digits is equivalent to 4 digits, just convert the individual hexadecimal digits into 4 digits, 4 binary digits. So for example, we have here a 7A3 of hexadecimal to binary. So first, for 7, we have 0, 1, 1. Yan. Wait. Hmm. 1, 2, 4. Tama, tama. So, we have E. So, 1, 1, 0, 1, 1, 0, 1, 2, 4, 8. So since 2 and 4, we have 10. So A. Okay. For E naman, so 1, 1, 1, 0, 1, 2, 4, 8. So 0, we have 2, we have 4, we have 8. 8 plus 4, we have 12, plus 2, 14. Okay, so we have E. So the last one we have 0, 1, 0, 0, 1, 1. So 1 and 2 lang, so equivalent to 3. So we have here. And then let's put it here, 0, 1, 1, 1, 0, 1, 0, 1, 1, 1, 0, 0, 1, 1. Okay? Hexadecimal conversion to octal. When converting a hexadecimal digit to an octal digit, you must first convert hexadecimal number to binary numbers and group it into 3, and then after that convert the group digits into octal by using concept of 1 of 4 to 1. So if the digit is not enough to form a group of 3, again you have to append zeros on the left sides of the digits. And then if the given hexadecimal have the fraction, when appending the 0 on the right sides of the given digits. Okay. So we have here steps. First, you have to convert hexadecimal digits in binary by considering the given digits, each given digits. So once it's already converted into binary group, to binary into 3, and using it 4 to 1. So for example, 7AE3. So again, ito yung answer kanina, no? So since if we group this, for example, this is one group, ito po, 100, ito po, then 011, ito po, and then 101, ito po, and then 111, ito po. Okay, so ignore po ito kasi nakagroup na po tayo. So if we get this, 1 plus 2, we get 3. 1, 2, 4, we get 4. 1, 2, we get 3. 1, 0, 1, 1, 2, 4, 5 plus, 1 plus 4, we have 5. 1, 1, 1, we get 7. So meaning 7, 5, 3, 4, 3 base 8. Okay, so each hexadecimal to decimal conversion. So each hexadecimal position is weighted with a power of 16. So the digits on the left sides of the radix point has a positive exponent, while on the right side of the radix point has a negative exponent. In converting a hexadecimal number to a decimal number is done by successively multiplying decimal number by 16 on the left sides of the radix. So if you have a fractional part of the given decimal successively multiplying the decimal number by 16 on the right side of the radix. Example, here are the steps. Place a number marker on the top of the given number by determining an exponent to be used. So get the individual digits and multiply it by base number 16 and raise it, and the exponent corresponds to a number marker you place on each digits when then do addition operations. We have here the example, 286A16 base 10, base 16 to base 10. So from here, digits 0, 1, 2, 3. So since this is base 16 po, base 10 binary. Okay, so 0 po, 0 to 7 po siya. 0, 1, 2, 3, 4, 5, 6, 7. Okay, so let's try to multiply, no, corresponding to for example, 2 times 16 yan, base 3, plus 8 times 16 is 2.
Okay na.
Ayan.
Paano mo charge mo?
So 8 times 16. So the total of this get 10,346 base then. Okay. So next we have adding subtraction. Adding and subtraction in number system. So the rules of binary, kung ang if the rules no, of course rules ng AND at saka rules of OR. Okay? So sa rules of AND which is addition. So sa rule ng AND 1 plus 0, 0 plus 0 is equal to 0, 0 plus 1 is equals to 1, 1 plus 0 is equals to 1, and 1 plus 1, 0, carry 1. Okay, so this is 1 plus 1, 0, carry 1, 1 plus 0, 1 plus 0 is equals to 1, wait, 1 plus 1 equals 0, carry 1, so may carry na po tayo, so 0. Then we have 1, 0 plus 0 equals to 0. Okay, so meron na tayong base 1. So 1 plus 0, we have 1. And 1 plus 0, another 1, so we get 1. The next 1 plus 1, 0, carry 1. And 1 plus 1, we have 0, another carry 1. And bring down 1. So we get 1 0 0 1 0 0. Another 1 plus 1, 0 carry 1. 0 plus 1 is equals to 1. Okay?
Bakit? Kakain mo to eh. Tatak pa kayo.
Oh,
Saan na ka?
So, okay, so this is the rule gap pa rin, no? So that we can get 1 1 0. So follow pa rin tayo. Okay, for example, this 1 1 plus 1, 0 carry 1. So mayroon tayong 1 dito. So 0 tayo dito, no? 0 plus 1 is equals to 1. Okay? So 1 plus 1, so 0 carry 1. And 0 plus 0, 0, 0 plus 0, 0. Then 1 plus 0, we have 1. And 1 plus 1, 0 carry 1. So 1, 0, 0 plus 0 equals to 0. So 1 plus 1, we have 1, 0 carry 1. 0 plus 0 equals 0. 0 plus 1, we have 1. 1 plus 1 carry 0. 0 carry 1. 0 plus 1, we have 1. Okay, so bring down 1. So, okay. For subtraction naman, we have here a rule, no? So same pa rin sa word sa ano, same din sa addition, you will just follow the rules. Okay? Yan. So okay. So dito sa subtracting binary numbers. So the first complement, that inverting by the numbers, 1 becomes 0 and 0 becomes 1 in the subtrahend. For those complements, done finding by one's complements of the binary numbers in the subtrahend, then add 1. So it's generally used because it will only have the one representations of the value of 0 compared to one complement. Ayan po. So, if we first complement, 0 becomes 1 becomes 0 and 0 becomes 1. Kasi second complement, you just 0 plus 1, we have 1, then bring down everything. Okay? So that's the difference between first complements and two's complements. One's complements and two's complements. Ayan po. So using one's complements, these are the steps. Okay? So just follow it. For the two complements, just follow it also. For addition of octal, ayan po. For example, 4 plus 6, so is equals to 10. So since 10 is greater than 7, so of course, we have to convert it to octal equivalent. Okay, so 2. Okay, so carry 1. So 1 plus 4 and 4 plus 5 equal to 2. Okay. Yan po. So for 10 divided by 8 is equals to 1, remainder 2. So remainder will be written as part of the sum of the quotient and will be carried over, no? So subtraction of octal number will also follow subtraction and the decimal numbers of decimal numbers. But instead of borrowing 10, you must borrow 8, no? And the next higher significant digits. Ayan po.
Ulit ko na. Ako nang pa.
Ayun to kanina. Okay. In addition and subtraction for hexadecimal numbers, so for hexadecimal numbers, just like how we did in octal numbers, so same rules pa rin in carrying and borrowing that is applied, but you have to note for the base, hexadecimal number is 16. So ito yung representation, no? Okay. Ayan. So 2 plus 10, we have 12. So kung 12 po siya, C. Okay? So for B plus 9, we have 11. 11 plus 9, we have 20. So you have greater than 50. So we will convert it to hexadecimal. So 20 divided by 16, we have 1, remainder 4, and 4 now becomes a part of the sum. So just carry it out here from 1. Okay? So on and so forth. Ang madali lang po yan. Subtraction hexadecimal, follow pa rin ng rules. Okay? Yeah. Okay? Thank you and God bless.